Hey, it's me again, Lori MacVittie, Distinguished Engineer and Chief Evangelist with F5. And we're here to talk about the Application Delivery Top 10. And this time I brought in one of the co authors of this list, Ken Arora. And we're going to talk about a few of the items. Ken, you want to introduce yourself so they know who you are?
Hi, folks. I'm Ken Arora. I'm also with the Office of CTO, distinguished engineer, and for a fair bit of my time at F5, a product architect as well. So happy to be here.
Awesome. Yeah, and you were instrumental in helping us work through this list and come up with it. Let's dig into ADC04, which is insufficient traffic controls, which is it sounds very lofty. Can you break it down? Like, what does that actually mean in terms of, delivering apps?
Yeah, so there's some themes. Some of these central themes show up over and over again. So let's talk about why, and then we'll talk about some of the solutions. So today's world lives in a world even more so than any time in the past, where we have fluctuating demand volumes, whether those are things like 9 a.m. is very different than midday or 2 in the morning, or whether it's things like sales or flash mobs, or you're looking at election results. We just had the election recently. And so you have a very high variability in demand volume. You might have normally maybe 1,000 users an hour, and something happens. You become popular in a meme or in the news, and all of a sudden you get 1 million users. That's 3 orders of magnitude. So you have these fluctuating demand volumes. You also have things that are going on because more of these workflows are being automated. So all these background tasks may be going on. Certainly you have backups. Those have happened for a long time. You might be doing CI/CD deployments. Things are going out. Now in the world of big data, right? You have data analytics workloads, training workloads that are going on while in your same infrastructure. And you might be using different servers, but they might be using the same network resources. They may be affecting how your routing works. So all these things are going on. um, we talked about the amount of load processing that's needed per request will change. It might change because of Gen AI, because prompts got bigger, because you're using RAG. As soon as you go to RAG, all of a sudden prompts got much bigger. That takes much longer as compared to a non-RAG enhanced Gen AI. Somebody rolls out a new CI/CD pipeline update, or goes to a different SaaS service because your applications are composed. Again, processing changes. So you have all of these things happening. Demands, volumes are changing, background tasks, processing. And so the old world of, I just do round robin scheduling just isn't sufficient anymore. And the ADC policy controls and the algorithms have a role to play, but there's other things that you can do, kind of now jumping to solutions. One part of the solution, we talked about edge computing a little while ago. Caching closer to the edge. I mean, this is what CDNs did, right? That was, you saw CDNs happening as kind of we moved as ADC evolved. And simple CDNs work well. You have write rarely, write occasionally, and read many times. Like I've got a simple video, I'm playing a Netflix movie. Okay, that's great for caching. But for Gen AI, every request, every prompt's different. You need fancier caching. You need semantic caching. So there's solutions there. We have malicious users. We also have just users who abuse a system. So another thing to do is just do rate limiting per client, rate limiting per geography, rate limiting of different kinds. And we see this in now the more advanced ADCs, where they have some amount of rate limiting, but that's really the more sophisticated delivery controllers that have that today. Big IP does, but many of the basic, if you just did a basic ELB, you may not get that. Sometimes an answer I sometimes hear is, I don't worry about it. I've got autoscaling. And, autoscaling is not, autoscaling has a role. I don't want to dismiss it. But if you think about it, most autoscaling, especially if you haven't optimized it, takes the order of minutes. I think an AWS study I read said 3 to 10 minutes was pretty typical. And they talked in that particular study, talked about optimizing it down to order of a minute. When you do that, that's still great. But you may need, if it's 30 seconds before the user, your client sees let's say something happens, and your user sees an increase of latency from a normal half a second to 3 seconds. They're not going to wait around for a minute for you to solve that, even if you've got autoscaling. Autoscaling is not going to solve that problem. You need to solve it through these other techniques, and we can talk through that. And then at the ADC itself, you have things like higher priority higher priority pools that you can send clients to, especially your higher quality. Like if somebody signed up for a higher level of service, your ADC needs to be powerful enough. Your policy needs to be able to do things like that, and understand that a background backup task can be deprioritized. So those are some examples. But to give you a feel, to summarize, insufficient traffic controls, the problems got a lot harder. There's a lot more variability. There's a lot more going on, and you need more sophisticated controls, both at your ADC policy level and at your infrastructure level, in order to deal with that. That's my short summary.
Yeah, I think you hit the nail on the head. I mean, when we say things like, rate limiting and QoS, right? Are we, color our bits, right? Back in the old days, we did a lot of these things at the network layer,
Mhm.
but it's no longer feasible for the network who's needs to be right routing and forwarding and doing its thing as fast as possible to also then go, well, who is this user and what's the app and what's the policy, right? It needs to move up the stack to something that's more aware of all of those different variables, the context, and then be able to apply the right policies to it. So,
Yeah.
yeah, this is huge. People forget that you can do it at many levels, right? Maybe your network is still helping, but when it comes down to that granularity, you really need to have an ADC, right, doing the right kind of traffic controls to keep everything balanced in there.
I totally agree. And those QS markings were made for a world where throughput is what mattered and not latency. And undifferentiated clients, all the things we talk about, like you said, this all makes sense. The other thing that some, and again, Big IP does a decent job at this, but again, we have all this information at the network layer, like the QS, DCP, DSCP markings, but does your load balancer actually look at that and use that? A lot of times they don't.
Yeah, it's something people should go look at to say, okay, how are we doing it? What do we need to balance? What are all the things, right? And then come up with maybe a better strategy in order to make sure that everything's optimized. So
Yeah.
it's great. And, this is only one of, well, 10 different, right, challenges we see. And we're kind of out of time for this one. But you know what? I'm going to bring you back to talk about another one that's related to traffic because you know your stuff. And, so we'll come back and we'll talk about that next time.